Okay, so here's our I can for today. This is 12.1. I can find arc length and area of a, would you write the word sector right here and name common angles? Okay, so maybe some new vocabulary for you. We're going to be talking about sectors on circles, and we're going to talk about common angles. Now, of the two, the common angles are actually more important. Okay, and we'll get to those at the end. You'll find that they're actually pretty easy when we're going to do part of the assignment today, just in the notes. It says, what's the formula for the circumference of a circle in the warm-up? And it says for part B, what's the formula for the area of a circle? Now, these are formulas that are going to come up over and over and over again, and you've got to have them memorized. So does anybody know the formula for the circumference of a circle? Dave?
Like 2 pi r.
He's right about that. It is. So we're going to write C equals 2 pi r. Nice memory there. The formula for the area of a circle looks kind of the same. Does anybody remember what the formula for the area of a circle is? This is going to come up over and over and over again. So if you don't have these locked in, I would get these memorized. Lizzie?
Random guess, 2 pi r squared.
Close. Really close. Mason?
Isn't it just pi r squared?
Just pi r squared. Okay? Pi r squared. So a lot of people get these confused because they both have a 2, they both have a pi, they both have an r. The way to keep these straight is just remember they've each got those three things, a 2, a pi, and an r. And the one that is measured in square units, area of something, that flat two-dimensional space, is measured in square units. So it's the one that's got the square, okay? So right here, I'm going to write in square units. So the 2 is not out front. The 2 is an exponent right here. Okay, and then the next question is a pretty easy one to figure out, I'm hoping. It says a pizza is cut into 12. We'll assume that they're equal slices. What's the central angle for each slice of pizza? I think Costco does this. Those gigantic pizzas, they cut them into 12. And they've got that little frame thing that shows them how to cut it. Yeah. 30. What? Yeah, 30 what? 30 degrees. Okay? 30 degrees. He's right about that. How did you get that, Si?
Because it's 360 degrees and then it's 12 slices.
So we just divide it, right? So we get 30 degrees. Okay? So we're going to be, so it's almost lunch. We're going to be talking about pizza today. So here's the deal. Remember that the measure of an arc is exactly the same as the measure of the central angle. So the measure of the arc is exactly the same as the measure of the central angle. Not if it's inscribed, not if it's outside, okay? But if it's a central angle, then it's exactly the same as the measure of the arc. And that's going to be important because we're going to kind of change the way we measure some things. So both the central angle and the intercepted arc are in degrees usually. So let's write degrees. But sometimes we want a more meaningful measurement. So it's not just, hey, this slice, whether it's on a pizza that's 10 feet wide or a foot and a half wide or whatever it is, this is our 30-degree central arc. We want a more meaningful measurement. So in example 1, this is what we've got. We've got an 18-inch pizza and it's cut into 12 slices. And we're going to use pi on our calculator and we're going to round to the nearest hundredth for each one of these. It first says how much pizza is contained in each slice, i.e., in other words, that is, what's the area of each piece? So we got to find the area of each piece. So our pizza looks like this. We're doing a piece that's 30 degrees. And how would we figure out the area of that slice of pizza? Dane?
You find the area of the whole thing and divide it by 12.
Find the area of the whole thing and divide it by 12. So here's what we're going to do. We're going to take the area of the entire thing, which is going to be pi r squared. Would you write down what r is? What's r, Wilson?
9.
R is 9. Very good. Okay. And then we're going to do 1/12 of it because that's 1/12 of the whole pizza, right? The 30 degrees. So this is going to be pi and 9 squared. So I'm going to pull up my calculator. Let's see, 1 divided by 12. And then I'm going to do pi. And then times 9 squared. And I got, if we round, 21.21. You good? Okay, 21.21 what? Square inches. 4 inches squared. Okay? And now, if I can, Dane did a little bit of math in his head. He did this part right here and he turned it into 112. So if I can just write down all of our thinking, the whole circle is 360 degrees. So we're going to take a fraction of that, which is going to be the 30 degrees out of the 360. And then we're going to do pi times the radius squared, so pi times 9 squared. Does everybody agree that this is how we did the calculation? That's like all the thinking written down. Okay, we'll come back to Dane. Dane, will you tell us how we're going to find how much crust there is? In other words, the length of the edge of that crust?
Just do circumference divided by 12.
Circumference and divide by 12. So that's going to be 2 pi times r, and we're going to divide that by 12. So I'll pull that up on the calculator. Let's see what we get here. 2 pi times r, and we're going to divide that by 12. And I got 4.71. Okay. Mason, 4.71 what?
Inches.
Yeah, because what we're after here is not the area. We're just after how much crust there is right here. We just want that little piece right there, right? So this is going to be inches. Okay, now, if I can, and if you'd write this down, all the thinking was this. 30 degrees divided by 360 degrees. There's the 1/12. And then there's the 2 pi times 9. There's the 2 pi times r. Everybody good with that? That's all the thinking that went into solving this? Okay. So here's a question for you, and I'm going to call on somebody, so everybody be on your toes. Don't let somebody else do the learning and thinking for you. What would happen if the pizza was 10 inches rather than 18 inches? So it's not one of those massive Costco pizzas. It's kind of like one of those 2-person pizzas, 10 inches across. What happens to the length of the crust? What happens to the area of the pizza? And what happens to the central angle? Zach?
They all become smaller and r becomes 5 instead of 1.
Okay, they all become smaller. Okay, raise your hand if you agree all of these become smaller. Okay, raise it up high. Okay, put them down. Raise your hand if you disagree. They don't all become smaller. Okay, so we're about 50-50. Okay, somebody that disagrees, would you politely explain your position? Luke?
The central angle stays the same because we don't lose any of the angles of the circle.
Yeah. So if we've got our circle right here and we do our slice of pizza right here, a smaller pizza is still going to have the same central angle, but we don't get as much pizza and we don't get as much crust. Is that right? So here's what would actually happen. The length of the crust, smaller. The area of the pizza, smaller. Central angle stays the same. Okay? Now, there are words for what we're talking about here. So the piece of pizza is a shape called a sector. And a sector is just a fancy word for a fraction of a circle created by a central angle. So when we say sector, we're always talking about a central angle. And in order to do the problems that we're going to do now and have some notation that's very common, we need to introduce the Greek letter theta, capital Theta, theta. This is the symbol. So theta, that's the symbol for theta. So x is the most common variable that we use for numbers. Theta is probably the most common variable that we use for angles. So we kind of want to automate and we want to write down a formula for the thinking that we had before so that we can generalize this. So here's how it works. If we want arc length, which we're going to use a script L for that, it's going to be theta divided by 360. It's going to be the fraction of the circle. We did 30 divided by 360. Then we times it by the entire circumference. So that's going to be 2 pi r. The area of the sector is going to be that same fraction of the circle times what, Dane? What goes inside here? You had it figured out earlier.
Pi r squared.
Pi r squared, okay? So if you're figuring out the length, the arc length is this piece right here. That's the pizza crust right there. Then we use this formula. It's that fraction of the circle determined by that central angle divided by 360 times the entire circumference. It's that portion of the circumference. And if we want the area, which is all of this stuff in here, then it's going to be that same fraction of the circle determined by the central angle theta divided by 360. That'll give us the fraction of the circle times the entire area. Any question? Okay, and look at the note. Okay, if the circle gets bigger or smaller, theta stays exactly the same. The central angle stays the same. So the fraction of the circle stays the same. But R and L and the area, so the radius, the arc length, and the area, they all get bigger or smaller accordingly. Okay? So this has an and right there. Would you circle the word and? Got a picture. 5 centimeters right here. We're going to do arc length, central angle, 72 degrees divided by 360. And arc length would be 2 pi, and we know the radius is 5 centimeters if we wanted to be exact. Okay, now, does anybody know what fraction 72 divided by 360 is? Throw it in your calculator. It's a fifth of a circle, okay? Now, I don't really care about that because most of the time we're going to throw these in there. I do care about this. I want you to notice something because this is going to be important over the next couple of days. Notice the top is in degrees and the bottom is in degrees. Degrees are a unit, so notice that they cancel. So notice this ends up being 1/5 of 2 pi times 5 centimeters. So the only unit on here is just centimeters. That's it. And if you throw that into your calculator, go ahead and throw it in. 1/5 times 2 pi times 5. Correct me if I'm wrong, but your calculator gives you this. 6.28. Fives cancel. Okay. The only unit is the centimeters, correct? Okay, so I'm going to change colors. The area would be the same 72 divided by 360. The degrees would cancel, and then it's going to be pi times 5 squared. So if I throw that into the calculator, I'm just going to pull this up. 72 divided by 360. I know it's 1/5, but I'm just going to throw it in as if we didn't know that. Then it's going to be pi times 5 squared. I hit enter, and I got 15.71. 15.71 what, crew?
Centimeters.
Close. Squared. Okay, we're talking an area. Okay.
Yeah.
So what we found here is the area is 15.71 square centimeters, and the arc length is 6.28 centimeters. So if this was a pizza, that's how much pizza we get, and that's how much crust we have right on the edge of the crust. Any questions? Okay. Would you do the arc length for this one and the area for this one? I'm going to freeze this. You get your answer round to the nearest hundredth. Go. Okay, when you're done, check with your neighbor. Check with at least one neighbor.
Yeah.
Right, left, front, back. Check with the neighbor. Wilson, did you check with the neighbor?
I just heard what Jack said. So
I did
You
too.
feel like you're good?
That's why I got look.
Oh, I can see from there. Yeah,
Me
these
too,
old
me
eyes.
too, me too.
well, I saw it as well.
Caleb, what'd you get for the arc length?
14.66.
14.66. Raise your hand if you got 14.66. Okay. And Jack, what about for area?
51.31 square.
Ooh,
Inches.
very good. Square inches here. And the other one, make sure the units are on there, are inches. Now, I don't want to belabor the point. I don't want to make a gigantic deal about this. But these are units. And if those didn't cancel, we'd have degree inches or degree inches squared or something weird like that. But that unit cancels off, so we literally just get a number. It's 1/3, a fraction of the circle there. Okay, any questions? Okay, we good with that? Okay, flip the page over. The thing that's different on example 3 is
No image.
there's no image for it. Does that make any difference?
No.
It doesn't. Okay, so I'm just going to be calling on people. I'm going to write L here, and then I'm going to ask Andy, tell me what to write down if the central angle is 135 degrees.
135 over 360.
Yep, keep going.
And then you find whatever that is.
3/8. Yep, it would be 3/8. Do we have to simplify it?
No.
No, you don't have to. Tell me what the rest of the formula is.
And then it's 2 pi and parentheses 5.
5 what?
Centimeters.
Technically centimeters. Now, I'll stop making a big deal of it, but make sure that the units cancel, and then your answer is going to be in centimeters here. Okay, and then we're going to do the area, and I'm going to ask Cy, tell me what the formula is for the area on this one. 3/8, which is the 135 over 360, right? Okay.
And then times pi. And then parentheses 5. And then squared.
Okay. And it would be centimeters squared, right? Jack, you got those answers?
Oh, yeah.
Oh, yeah.
Come on, Jack.
Come on, Jack.
Yeah, I got it out. Pretty cute.
Just making sure this one is asking for that word there, right?
Yes.
Because it doesn't have an X.
Yeah.
Okay.
You're right. Oh, go ahead and set this on. Dane, what'd you get for the length?
I did not do it yet.
Ooh, haven't done it yet. Huh.
I'm sure I would
I
get
did.
it right if I did.
Jack did it. Jack, what'd you get?
11.78 centimeters.
Luke, 11.78?
Yeah.
Cy?
Centimeters.
11.78 centimeters. Perfect. Next one. Lizzie, you got this one for us? 29.45. Raise your hand if you got both of those right. Really? Okay. All right. Crew, tell me how to set up this one.
Ah. All right. So, hold up. Okay, it's 210 over 360. Then times by like 2 pi 10 or 2 pi then like parentheses 10 meters.
I'll take that. Perfect. Okay. Wilson, tell me how to set up the area.
Well, 210 divided by 360, which is 7 over 12.
7/12. Perfect. Do we have to reduce it?
No, yeah.
You can if you want to. Yep, might be helpful somewhere. And what's the formula for the whole area here?
Pi 10 squared.
Pi 10 squared. 10 meters squared, right? Okay. All right. Now, I want everybody to watch. I'm going to make one tiny change to this. Okay. What if this had said the diameter is 50? Luke.
We just use 25 as our
Yeah. Then you just use 25. You make sure you have the units. Okay. Caleb. What does L stand for?
The arc length.
Arc length. So the arc length is a fraction of the circle, right? Divided by 360 times 2 times pi times r. So in this case, we've got the arc length. So this is 25.29. We could put the feet on there. This is theta. Do we know theta?
No.
Don't. We do know it's divided by 360. That would be degrees, and that would be degrees. And then this is going to be 2 times pi times, whoops. Let me get the 2 pi in here. 2 pi and then times 10. What are we solving for, Jack?
Theta.
We're solving for theta. We're missing the angle theta. We don't know the central angle. Notice that the degrees cancel. Okay, and then I'm going to zoom in on this just a little bit. Could we do anything to simplify this just a tad? Yeah.
Multiply both sides by 360.
We could multiply both sides by 360. We could definitely do that. Okay, isn't this stuff just a fraction? Could I cancel the 10?
No,
Why not?
because the degree thing.
We canceled the degree already right here.
Oh,
So can I cancel the 10?
I guess.
Yep, I can. So this is really, let me just write this out. This is 25.29 equals, this is theta, and then we've got a 2 pi over 360. That's really what we've got. Now, we could clear the fraction by multiplying by 360, or we could take advantage of the fact that in 7th grade math, or for you guys, maybe in 6th grade math, isn't that just a fraction that we need to get rid of? How do you get rid of a fraction? Multiply by its reciprocal. So we're going to multiply by 360 over 2 pi. Oh, 36. Yeah, 36. Thanks. Yep, thanks. 2 pi over, 36 over 2 pi. So theta in this case, let's throw that in the calculator. Shrink this down just a tad. Slide it over. Whoops. So 36 times 25.29, and we're going to divide that by, make sure the 2 pi goes in parentheses if you do this. So 2 and pi. If you don't put it in parentheses, you're not going to get the right thing. Is there any way that can be the right answer?
I don't think so.
What did I do wrong?
You have to divide by 2 pi.
Yeah, I just hit the wrong button, which happens all the time on here. 144.90 degrees. Okay, 144.90 degrees. Okay, any questions?
So many questions.
I get it.
You do?
Well, it's
Okay.
just like a lot of.
There are a lot of numbers floating around there. Okay, Zach, what's missing on this one?
The radius.
The radius is missing on this one. Okay, radius is missing on this one, and it gives us an area. So the area of 536.94 is going to be equal to the central angle, 190 over 360. Pi r squared. Crew, can I cancel those zeros? Yep.
That's what I'm at.
Isn't this 19 pi over 36 r squared?
Checks out.
Isn't that just a fraction in front of the variable? Can I multiply by the reciprocal?
You sure
So
can.
36 over 19 pi, and that 19 pi better go in parentheses. So let's throw that in the calculator and see what we get. 36 times 536.94, and then we're going to divide by, it's got to go in parentheses, 19 pi. So 323.8357. Oops.
It's a big ring.
Oh, yeah, it's square.
You gotta do the square.
What do we have to do?
Square.
Square root.
Take the
Okay,
square
so take the square root. And can we have a negative?
root.
So I'm just going to hit second square root, second answer, so that way I don't have to type the entire thing in there. How about a radius of,
17.
take a look, what is it?
I mean, yeah, that's what I meant.
18, yeah, 17.995. So the radius on this one would be 18 what?
Oh,
Feet.
Feet.
Just feet.
Okay.
When we go back to A, where'd you get the degree from? On the answer.
Oh, so what we did, so theta is in degrees. We could have left that, and that would have left a degree on here. Okay. So the theta is the central angle.
All right.
All right. Okay. Not too bad, right? No? Okay. Real quick. Last thing. Would you write the word common right here? The only other thing that we're going to do is we're going to write down some common angles, and I want you to keep track of these. These are going to get cemented in your brain over the next couple of weeks, and then you're never going to forget them. The common angles are multiples of 30, 45, and 60, and there's a nice way to write them down, and part of your assignment is to actually just reproduce this. So by convention, we start right here. We start here at 0. And then I'm going to go around the circle in quarters. So this would be 0, 90 degrees, 180 degrees right here, 270 degrees right here, and 360 degrees right here. So if we go in quarters of a circle, we go 0, 9, 18, 27, 36. Then 30 degrees. That's the next one that's common. Now, I can go through and label the other ones, but I want you to notice this. If this is 30 degrees above the x-axis, if you want to think of it, this would be 30 degrees above the x-axis over here. So we would just subtract 30 degrees. So this would be 150. And here you would add 30 degrees. So this is going to be 210. And over here, because we're going kind of backwards, we'd subtract 30 degrees. So this is going to be 330 degrees. This one's 45 degrees, which means the one over here is 180 minus 45, so this is 135. This one's 180 plus 45. Help me out. 225. And this last one would be 360 minus 45 degrees, 315 degrees.
Yes.
Okay? And then the last one are the multiples of 60. So this is going to be 60 degrees. This is another 60 degrees here, or it's 180 minus 60 degrees. So this is going to be 120. 180 plus 60 degrees. So this is 240. And what's this one? 300 degrees. Okay? Now, part of your assignment, there's a problem on your assignment where all you have to do is you just have to recite those. You just have to go around the circle and know that we go 0, 30, 45, 60, 90, 120, 135, 150, 180, and so forth. Everybody good there? Okay. The last part of the notes just say this. What's the fraction of a circle represented by 180? What is it? 1/2. By 90?
4.
1/4. By 45?
1/8.
1/8. 300?
5/6.
5/6. Okay? So earlier you were reducing fractions and stuff like that. That can be helpful. And when we do the assignment tomorrow, you're going to see why it's really helpful to know about those fractions. Okay? So would you rate yourself on how you're feeling about arc length and sector and common angles right now? And then would you make sure that by tomorrow you've got the